Right. So we want to look at the question, does the integral give the area between graph of a function and the x-axis. Okay. Now to look at this question, we're going to go ahead and consider the function f of x equals x cubed on the interval -2 to 2. So let's draw the graph of that function. So that's the graph of f of x equals x cubed on the interval -2 to 2. If we construct the integral from 0 to 2 of x cubed dx, you can calculate that fairly quickly as equal to 4. So the area underneath the curve here, which I will go ahead and mark in green, has a value of 4. So in this case, the integral does give the area between the graph of the function f of x equals x cubed and the x-axis, because the green area is 4. That's also the value that we get when we do the Riemann integral. Let's consider a different integral. Let's consider the integral from -2 to 2 x cubed dx. Again, we get x to the 4th over 4, by the way, from -2 to 2. We can show that that's equal to 0. So what this is telling us is that the integral from here to there is equal to 0. Now, if you look at the graph, it's clear that the area, which I've written or shaded in green, is not equal to 0. Okay. It's pretty easy to see that since this function is odd, that the area between 0 and 2 is 4, and the area between -2 and 0 is 4. So the area between the function f of x equals x cubed and the x-axis between -2 and 2 is actually equal to 8. So how do we reconcile the fact that we get an 8 here and we're getting a 0 here? Well, we have to talk about something called signed area. So let's talk about signed area. Now with signed area, what we're going to say is that if the area is above the x-axis, then we're going to say that the signed area is positive. So in this case, we would go ahead and say the signed area of this region right here is plus 4. If the area is below the x-axis, then we say the signed area is negative. So in this case, we would say that the signed area for the region between 0 and 2 is minus 4. If we add these signed areas, so if we take this signed area and this signed area, and we add those together, lo and behold, we get the 0, which is what we got over here when we did the integral. So the way to think about the integral of a function is not to think about it as the area between the graph of a function and the x-axis, but it's to think about the signed area between the graph of a function and the x-axis. We see that f of x equals x cubed is an odd function. Since it's an odd function and we're integrating the odd function over an interval centered at 0, we will always get a value of 0.